chart right here, we're dealing with columns. All right, we talked about our formula for direct variation. You should have y equals k times x, and then raise it to the power of n, because you can still have a direct variation problem even if you're dealing with powers. So, for example, this could be an example problem. You could have y equals 6x squared. That could be a direct variation problem. What does k represent in this? We talked about it yesterday.
Constant of variation.
The constant of variation. So, in this particular example, if I asked you what the constant of variation was, what would you say the constant of variation was in this example? Right? 6. Yeah, that would be the constant of variation. Okay? So in your journal, something that you need to have right here, this is your standard form for direct variation. Y equals k times x to the power of n. Okay? In this particular case, our n value was a 2. All right? If you ever wanted to solve for k, let's say right here it wasn't you weren't able to easily recognize that you had a k value. K is always equal. Go back real quick. K is always equal to your y value divided by your x value to whatever power you have. So this is the other formula I need you guys to have in your journal. Y equals k x to the n, and k equals y divided by x to the power of n. The last formula that I would like you guys to have in your journal, all right, is if you have a bunch of x variables and y variables that you're comparing, and you know it's direct variation, here's how you can set it up. You can place, if you have two different y values, you can set the y values equal to each other. If you have two different x values, you can set them up as a proportion. And then whatever n value you have right here, you raise that exact same to the power of n. And we're going to do some example problems with this. But I also want you guys to have this. This is a proportion. You also need to be able to set up a proportion to solve direct variation problems when you have multiple variables in a given situation. We'll have some example problems to do this so you understand how to use this, how to use this, and how to use this. But right now in your journal, this is what you need to have. The next thing we're going to talk about is this thing called inverse variation. Okay? An inverse variation, y is inversely related to x. We're going to say y is going to equal k, your constant, divided by, constant of variation, divided by x to the power of n. So I want you guys to look at the difference between direct variation and inverse variation. All right? Our k value is going to equal your x value to the power of n times your y value. So this time, your constant's not y divided by x to the power of n, it's actually x to the power of n times y. So here's an example of what an inverse variation problem would look like. By the way, k is still considered to be your constant of variation in both scenarios. If I said y equals 8 divided by x to the power of 3, this right here would still be an example of direct variation. Inverse variation. So what's our k value this time for this problem? 8. 8 is our k value. Very good. All right, it's our constant. All right, and what's our power this time? It's our n value. Our n value is a 3. Okay, so there's your n value right there. So if you're dealing with this problem, this would be y is equal to 8 divided by x cubed. just like I had an equation right here, I'm going to set up an equation over here where you have, if you have multiple x variables and y variables in a problem and you know it's inverse variation, here's what I want you to do. Do x1 to the power of n times y1 will equal x2 to the power of n times y2. This is how you would set up equations dealing with inverse variation. Okay, not direct variation, but inverse. This is an inverse relationship. By the way, if you ever had the robotics class where you had to deal with gear ratios, you learned that the gear ratios work inversely. They don't work directly. Okay. All right. Remember having to solve all that. Okay. Now, the last one is dealing with joint variation, where you have things a lot. You have more than just your x and y variable. You actually have a z variable. So your joint variation problem is y equals k, which is still your constant of variation, times x to the power of n times z to the power of n. So now you're dealing with a lot of stuff going on. All right? So let's see here. What could be an example for a joint variation problem? All right? Here's an example. You guys have probably seen this before. Volume equals length times width times height. You have three variables that are jointly working together. Okay, that's a joint variation problem. All right, or you could say area is equal to what? Area is equal to length times width, where you're dealing with things that are being joined together. So, for example, we had an equation y equals 8x to the third z squared. This would be a joint variation problem. Once again, your constant still what?
8.
Still 8. So your constant variation right there, there's your constant, your k value. So in all of these problems, everybody, in all of these problems, you're going to have a constant of variation that you could be asked to solve for. Okay? So what is your k value going to equal this time? So your k value will always equal whatever your y value is divided by x to the power of n and z to the power of n. Now, notice a little pattern here. Noah, right here we have y over what? X to the n. And then here we have y1, x1. Here we have x to the power of ny. Notice we have x times y, right? So how are we going to set this guy up as an equation where we can set up maybe a proportion, kind of like this one? We're going to have one y value. Then we're going to have an x value raised to the power of n, a z value raised to the power of n, and what do you think that's going to equal on this side? y2, x2 to the nth power times z 2 to the nth power. So these are, by the way, these are the three formulas that you will be using, but you have to know whether you're dealing with direct variation, inverse variation, or joint variation. Okay? So when you're doing problems, you got to figure out which one of these are you working with. And once again, every single time, k refers to the constant of variation. That's the constant that's within the problem. All right, let's look at number one. Okay. First of all, we're gonna be kind of identify what type of variation is going on. So what I'd like you to do on your papers is rewrite this if you would. All right. Put negative x squared over y and set that equal to 3 over 1. Okay. Because we're going to solve for y in number one. Now, hopefully you recognize that we're now dealing with a proportion where our cross products will be equal. All right? So what is 3 times y? 3y. All right, we got 3y equals a negative x squared times a 1. That'd just be a what? Negative x squared, right? Now, what would be my final step in this? Divide by 3. So we're going to divide this side by 3 and this side by 3. And let's look at our final answer. Our final answer is y is equal to a negative x squared over a 3. Now, this version, it's kind of hard to think about what the k value is. So let's write it like this. If I say y equals negative 1/3 of x squared, these actually mean the exact same thing. So when we go back, by the way, what do you guys think your k value is?
3.
Nope.
1.
Nope.
Y.
Nope.
2.
Nope.
1/3.
Negative.
Close.
-1/3.
Negative 1/3 is correct. Negative 1/3 is your constant of variation. That's the number right out here, everybody. That's the number right here. That is your k value. So let's go back. You guys look at this really carefully. Look at this carefully. We're going to go back to this and ask yourself, which one of these 3 does it look most like? Does it look like direct variation? Does it look like inverse variation? Or does it look like joint variation? I'll go back. You have it in your journal. Okay. By the way, let's replace this. What is negative 1/3 equal to? That's equal to our k. So this is actually a y equals a k times an x to the power of n. It is direct. So this right here, this is a direct variation problem. If I can spell direct correctly. All right? So this is a direct variation. So now we're going to write a statement. Okay? This is the statement you guys need to get good at writing. We're going to say y varies directly with x squared. Y varies directly with x squared. And when it says, write a statement of variation relating the variables of each equation, then name the constant of variation. Well, this is the statement right here. This is the statement of variation. And what is our constant equal to in this? So it says name the constant. Our constant was a negative 1/3. So this is your final answer to number 1. Y varies directly with x squared. Or you could say with the square of x. You could say that as well. All right, and our constant is equal to negative 1/3. That's what I'm looking for